The celestial cartography archives of the Nexus Collective contained millions of planetary entries, each reduced to a simple data point. Earth was barely a footnote, a classification marked as Developmental Stage 2, Pre-Unified Civilization, with a notation of minimal interstellar potential. The planet's coordinates were so unremarkable that most deep space navigation systems used it merely as a reference point for more interesting stellar landmarks. Dr. Kael'Zar, a senior xenoanthropologist from the Astral Observation Bureau, had spent decades studying emerging civilizations. His office, a zero-gravity chamber filled with holographic projections of various planetary systems, contained thousands of files documenting species on the brink of either remarkable evolution or complete self-destruction. Earth's file was thin, almost translucent, a collection of fragmented observations that suggested a species of remarkable contradiction. The human civilization appeared to be simultaneously its own greatest threat and most incredible promise. Satellite data showed a planet of extreme contrasts, regions of breathtaking technological innovation existing mere kilometers from areas struggling with fundamental survival challenges. Their communication networks were a chaotic web of information, simultaneously connecting and dividing their global population. Most alien observational teams had long since written off humanity as a species too fractured to achieve any meaningful cosmic significance. What those observers failed to understand was the true nature of human potential. Unlike the highly structured civilizations of the Nexus Collective, humans possessed an almost chaotic ability to innovate through conflict, collaboration, and unexpected creativity. Their technological progression was not linear but explosive. Moments of seemingly impossible breakthrough would emerge from the most unlikely circumstances. The most recent comprehensive report on human civilization, compiled by the Galactic Developmental Assessment Team, read like a paradox. Their technological capabilities were advancing at an exponential rate that defied conventional understanding. In the span of mere decades, they had transitioned from basic powered flight to exploring the edges of their solar system. Communication. Technologies evolved with such rapid complexity that traditional monitoring methods became increasingly ineffective. Orbital monitoring stations continued to track human activities with a mixture of boredom and mild curiosity. Standard protocols suggested minimal intervention for developing species, allowing them to progress or collapse based on their own internal dynamics. The humans remained blissfully unaware of the countless alien civilizations that had passively observed their planet for generations. What made Earth truly unique was its environment of constant, controlled chaos. Unlike other developing civilizations that followed strict developmental paths, humans seemed to thrive on unpredictability. Their scientific community operated through a complex ecosystem of competition and collaboration that continuously pushed technological boundaries. Universities, private research institutions, and independent innovators created a dynamic landscape of constant reinvention. The planet's geopolitical structure added another layer of complexity. Multiple independent nations with different governmental systems, economic models, and cultural perspectives created a constant state of dynamic tension. Where other civilizations would have fractured under such diverse pressures, humans seemed to generate innovation through their differences. Quantum communication arrays in the outer solar system monitoring stations continued to record human transmissions. Each new data packet brought another surprise, a scientific breakthrough, a technological innovation, or a cultural shift that challenged existing understanding. The sheer unpredictability of human development made them an anomaly in the carefully cataloged records of emerging civilizations. Dr. Kael'Zar often found himself fascinated by the human potential. His colleagues viewed Earth as a minor, inconsequential planet, but he saw something more, a species on the verge of a transformative moment. The signs were subtle, but unmistakable. Their scientific publications suggested they were close to several breakthrough technologies that could fundamentally alter their developmental trajectory. Little did the Nexus Collective know that the pale blue dot they had casually overlooked was about to become the most significant discovery in galactic history. Humanity was not just another developing species. They were a force of nature waiting to be unleashed. The universe was about to learn a profound lesson about underestimation. The laboratory at the Global Collaborative Research Center hummed with an electricity that had nothing to do with its advanced equipment. Dr. Maya Rodriguez stood before a holographic display, her fingers tracing complex quantum equations that seemed to dance between possibility and impossibility. Outside the reinforced windows, Santiago's early morning light began to paint the research complex in shades of gold and silver. Maya's breakthrough had begun as a seemingly impossible thought experiment. Traditional quantum mechanics suggested strict limitations on energy manipulation and information transfer. But what if those limitations were not hard barriers, but merely unexamined boundaries? Her team had been working for years on a theoretical framework that challenged fundamental understanding of quantum entanglement. The breakthrough came from an unexpected intersection of disciplines. Maya's background in quantum physics merged with insights from neural network theory, computational biology, and an unconventional approach to material science. Her colleague, Dr. Hiroshi Nakamura, had contributed critical algorithms that allowed for dynamic modeling of quantum states previously considered unstable. Their first successful demonstration was almost anticlimactic. A small prototype device, no larger than a standard laptop, generated an energy field that could potentially modify its own quantum state in real time. Initial tests showed capabilities that defied current scientific understanding. The device could adapt its molecular structure instantaneously, responding to environmental changes with a complexity that mimicked living systems. Global research institutions immediately took notice. The implications stretched far beyond theoretical physics. Potential applications ranged from revolutionary medical treatments to unprecedented space exploration technologies. Governments and private research centers began allocating unprecedented resources to expand on Maya's initial discovery. International cooperation became a necessity. Traditional competitive barriers between research institutions dissolved as scientists recognized the magnitude of the breakthrough. A global network formed, sharing data, resources, and collaborative research in ways that had never been possible before. The most brilliant minds from every continent began working towards a common goal of understanding and expanding the new quantum manipulation technology. The financial world watched with intense interest. Venture capital firms and national research foundations competed to support the most promising research teams. But this was more than a technological revolution. It was a fundamental shift in how humanity understood its place in the universe. Dr. Elena Petrova, a leading researcher from the Russian Academy of Sciences, described the breakthrough as a moment when humanity's understanding of physics transforms from observation to manipulation. Her team began exploring applications in energy production, developing prototypes that could generate clean, sustainable energy through quantum resonance. Military research institutions initially attempted to classify the most critical findings. But the nature of the discovery made complete secrecy impossible. The quantum manipulation technology was fundamentally about information and adaptation. Trying to control it completely would be like trying to cage light. Universities around the world began redesigning entire scientific curricula. Physics departments expanded to include interdisciplinary studies that blended quantum mechanics with biological systems, computational theory, and material science. A new generation of scientists emerged, trained to think beyond traditional disciplinary boundaries. The first practical demonstrations came faster than anyone expected. A prototype medical device could now adapt its molecular structure to target specific cancer cells with unprecedented precision. Space exploration teams developed initial designs for spacecraft that could modify their structural integrity in response to extreme environmental conditions. Maya Rodriguez found herself at the center of a global transformation. Interviews, research, proposals, and invitations from scientific institutions around the world competed for her attention. But her focus remained on the fundamental question that had driven her research. What are the true limits of human potential? In research laboratories, university lecture halls, and collaborative networks spanning the globe, a new understanding was taking shape. This was more than a scientific breakthrough. It was the first clear signal that humanity was about to change. the fundamental rules of what was possible. The unexpected spark had been lit, and no one could predict where its light would ultimately reach. The transformation began subtly, almost imperceptibly at first. Research centers around the world started connecting in ways that defied traditional scientific collaboration. What had once been closely guarded institutional secrets became part of a rapidly evolving global knowledge ecosystem. The International Adaptive Technologies Consortium emerged as the epicenter of this new approach. Established in a converted research complex nestled between the Andes Mountains and the Pacific coast, the facility represented a radical departure from traditional research models. Here, scientists from every conceivable background worked together in open-plan laboratories that resembled living, breathing organisms of innovation. Dr. Kamau Okonkwo, a systems theorist from the African Technological Innovation Hub, had been one of the first to recognize the potential of this new collaborative approach. His groundbreaking work on adaptive network systems provided the theoretical framework for what would become known as the Global Cognitive Network. The system allowed research teams to share insights, computational resources, and breakthrough moments in real time, creating a collective intelligence that was far more powerful than any individual institution. The first major breakthrough came from an unexpected collaboration. A team of material scientists from Japan worked simultaneously with quantum physicists from India and computational experts from Brazil. Their joint project developed a new class of adaptive materials that could fundamentally change how humans understood the relationship between technology and environment. Prototype technologies began to emerge at an unprecedented rate. An adaptive medical nanite system developed by a team of researchers could now modify its molecular structure to treat previously incurable genetic disorders. Space exploration technologies evolved from static designs to dynamic systems that could reshape themselves in response to extreme planetary conditions. Educational systems underwent a radical transformation. Traditional academic boundaries dissolved as interdisciplinary approaches became the new standard. Universities redesigned entire curricula to focus on adaptive thinking, collaborative problem-solving, and cross-disciplinary innovation. Students were no longer confined to single fields of study, but were encouraged to explore the intersections between different scientific and technological domains. The Global Cognitive Network revealed something profound about human potential. Traditional models of competition were replaced by a more complex approach to innovation. Research teams discovered that sharing knowledge accelerated discovery far more effectively than protecting intellectual property. A young researcher in a small laboratory in Kenya could now contribute to a global project with the same impact as a well-funded institution in Silicon Valley. Dr. Elena Rodriguez, no relation to Maya Rodriguez from the initial quantum breakthrough, developed a revolutionary approach to artificial intelligence. Her cognitive adaptive networks created AI systems that could learn, modify, and improve themselves in real time. These were not simply machine learning algorithms, but dynamic intelligence systems that could adapt to complex changing environments with unprecedented flexibility. Space exploration took a quantum leap forward. The International Stellar Exploration Consortium developed modular spacecraft designs that could reconfigure themselves mid-journey. Communication systems became so advanced that they could predict and adapt to potential challenges before they fully materialized. What had once seemed like science fiction became achievable reality. Environmental restoration projects demonstrated the true potential of adaptive technologies. Teams developed ecological repair systems that could analyze and respond to complex environmental challenges. Damaged ecosystems could now be restored using technologies that understood and worked with natural systems rather than attempting to control them. The most surprising aspect of this global transformation was its organic nature. No single institution or government controlled the process. It was a truly collective human endeavor, driven by a shared understanding that humanity's potential was far greater than anyone had previously imagined. Dr. Kamau Okonkwo often spoke about this moment in his lectures. "We are not just developing new technologies," he would say. "We are reimagining what it means to be human. Our greatest strength has always been our ability to adapt, to learn, to grow beyond our current limitations. As the year drew to a close, it became clear that something extraordinary was happening. Humanity was no longer just a species struggling on a small planet. They were becoming something more. A collective intelligence capable of transforming not just their own world, but potentially the entire universe. The seeds of transformation had been planted, and they were about to bloom in ways no one could have predicted. The transmission arrived on a quiet Tuesday morning at the Global Interstellar Communication Center. Located in a converted research facility in New Zealand, the center had been established to handle potential extraterrestrial communication with a combination of scientific rigor and human creativity. Dr. Aisha Nadir, the lead communication specialist, was reviewing routine deep space signal logs when the unusual pattern appeared. Most researchers would have missed the subtle anomaly, a complex quantum-encoded signal that seemed to shimmer between different dimensional frequencies. But Aisha's team had been preparing for this moment, developing communication protocols that went far beyond traditional radio wave interpretations. The signal's complexity was unlike anything previously encountered. Traditional decryption methods failed completely. Instead, the team employed the adaptive quantum communication networks developed from Maya Rodriguez's earlier breakthrough. The system began to analyze the transmission not as a linear message, but as a multidimensional information construct. Hours turned into days as the global research network collaborated to understand the transmission. Universities, research centers, and communication experts from every continent worked together, sharing computational resources and theoretical insights. What emerged was far more than a simple greeting. It was a comprehensive assessment of humanity's potential. The Nexus Collective, it seemed, had been observing Earth for far longer than anyone had imagined. Their transmission was simultaneously a diplomatic overture, a scientific evaluation, and a test of human capabilities. Each layer of the message contained multiple levels of meaning, challenging the receiver to demonstrate not just technological understanding but conceptual creativity. Dr. Rafael Martinez, a linguistic expert specializing in xenocommunication, described the transmission as a multidimensional puzzle designed to assess our cognitive flexibility. The message contained complex mathematical proofs, cultural references that spanned human history, and embedded challenges that required simultaneous scientific, artistic, and philosophical interpretation. The global response became a testament to human collaborative potential. Research teams from different disciplines worked together in ways that defied traditional academic boundaries. Quantum physicists collaborated with cultural anthropologists. Mathematicians worked alongside poets and musicians to decode the deeper layers of the transmission. What made the human response truly unique was its approach. Instead of a defensive or purely scientific reply, the transmission team crafted a response that was simultaneously precise and creative. The message included a comprehensive mathematical proof demonstrating humanity's understanding of advanced quantum principles, a cultural compilation that showcased the diversity of human, artistic, and philosophical thought, a series of adaptive communication protocols that invited further dialogue, subtle humor, and cultural references that demonstrated humanity's capacity for nuanced communication. The Nexus Collective's monitoring systems were unprepared for such a response. Their initial assessment of humanity as a primitive, potentially dangerous species began to transform. This was not a simple first contact scenario. It was an invitation to a fundamentally new type of interstellar dialogue. Dr. Nadir remembered the moment the final transmission was compiled. The research center fell silent, understanding that they were witnessing a pivotal moment in human history. The message was not just a response to an alien communication, it was a declaration of humanity's potential. Global media struggled to comprehend the significance of the event. Traditional news networks ran endless speculation segments, while scientific publications attempted to break down the complex nature of the transmission. But the true significance was understood by those who had been part of the collaborative effort. Preliminary analysis suggested that the Nexus Collective had been conducting a sophisticated assessment of humanity's developmental potential, Their transmission was less a simple greeting and more a comprehensive test of species-level cognitive capabilities. As the days passed, subtle changes began to occur in global research and diplomatic circles. Funding for interdisciplinary research increased dramatically. Educational systems began to emphasize adaptive thinking and collaborative problem-solving. The first contact event had become a catalyst for global transformation. Dr. Rafael Martinez captured the moment perfectly in a later interview. "We didn't just receive a message from another civilization. We demonstrated that humanity is capable of becoming something far greater than anyone had ever imagined." The universe was about to learn that first impressions can be wonderfully misleading. The Quantum Adaptive Systems Laboratory sat nestled in the mountains of Chile, a gleaming complex that defied traditional architectural design. Its walls seemed to shimmer and change, reflecting the very technologies being developed within. Dr. Sophia Chen stood before a holographic display, watching as molecular structures danced and reconfigured themselves in real time. Humanity's technological evolution had entered a phase that previous generations would have considered pure fantasy. The biomechanical interfaces developed here represented more than just a scientific breakthrough. They were a fundamental reimagining of the relationship between living systems and technology. The core of this technological revolution was the adaptive quantum network first conceptualized by Maya Rodriguez. What had begun as a theoretical framework had now become a living, breathing technological ecosystem. Communication systems no longer simply transmitted information. They anticipated, evolved, and responded to complex environmental challenges, with an intelligence that blurred the line between machine and organism. Dr. Carlos Ramirez's team had developed medical nanites that could navigate the human body with unprecedented precision. These microscopic machines could diagnose, treat, and prevent diseases by adapting their molecular structure in real time. A patient with a complex genetic disorder could now receive treatment that modified itself continuously, addressing the unique complexities of their individual biological system. Space exploration technologies underwent a complete transformation. The International Stellar Exploration Consortium developed spacecraft that were less machines and more living entities. These vessels could modify their structural integrity, energy consumption, and navigation systems instantaneously. Radiation, shielding, propulsion mechanisms, and life support systems became dynamic, responding to environmental challenges before they could become critical. Communication networks evolved beyond simple data transmission. The global cognitive network developed by Dr. Kamau Okonkwo had become a form of collective intelligence. Research centers, educational institutions, and collaborative platforms could now share knowledge and computational resources in ways that mimicked neural networks. Information no longer flowed in linear paths but existed as a dynamic, adaptive ecosystem. Environmental restoration projects demonstrated the true potential of adaptive technologies. Teams developed ecological repair systems that could analyze complex environmental challenges and develop targeted solutions. Damaged ecosystems could be restored using technologies that worked in harmony with natural systems, understanding and responding to intricate biological interactions. Dr. Elena Rodriguez's work on cognitive adaptive networks pushed the boundaries of artificial intelligence. These were not simple machine learning algorithms, but dynamic intelligent systems that could learn, modify, and improve themselves in real time. The AI developed here could collaborate with human researchers, offering insights that transcended traditional computational limitations. The most surprising developments came from unexpected intersections of technology. Architectural design merged with biological systems to create living buildings that could adapt to environmental changes. Energy production systems could modify their output based on complex environmental and social needs. Transportation networks became fluid, dynamic systems that could reconfigure themselves to optimize efficiency and reduce environmental impact. Global educational systems underwent a radical transformation. Traditional academic boundaries dissolved as interdisciplinary approaches became the new standard. Students were trained not just in specific fields of study, but in adaptive thinking, collaborative problem-solving, and the ability to navigate complex, rapidly changing technological landscapes. Dr. Sophia Chen often reflected on the profound implications of these technological developments. During a global conference, she shared her perspective. We are not just developing new technologies, we are reimagining what it means to be human. Our greatest strength has always been our ability to adapt, to learn, to grow beyond our current limitations. The Nexus Collective continued to observe these developments with increasing fascination. The technological ecosystem emerging from Earth defied their most sophisticated predictive models. Humanity was not just developing technology. They were creating a new form of intelligent adaptation that challenged fundamental understanding of technological progression. As the year drew to a close, it became clear that something extraordinary was happening. Humanity was transforming from a species limited by technological constraints to a dynamic, adaptive civilization capable of reimagining the very foundations of technological possibility. The adaptive frontier stretched before them, limitless, unpredictable, and filled with unprecedented potential. The encounter began at the edge of the solar system, where the last wisps of solar radiation gave way to the infinite darkness of interstellar space. The human exploration vessel Horizon Nova carried a crew of 12, a carefully selected team of scientists, engineers, and adaptive system specialists who represented the pinnacle of human collaborative potential. Captain Aria Rodriguez sat at the central command interface, her fingers dancing across adaptive quantum displays that seemed to anticipate her intentions before she could fully form them. The ship itself was more than a vessel. It was a living system that could modify its structural integrity, energy consumption, and strategic responses in milliseconds. The Nexus Collective Patrol appeared without warning. 3 massive vessels emerged from quantum fold space, their angular designs a stark contrast to the organic flowing lines of the Horizon Nova. Traditional military doctrine would have suggested immediate evasive action or defensive positioning. But this was not a traditional crew, and this was not a conventional encounter. Dr. Hiroshi Nakamura, the ship's primary systems analyst, began a complex series of quantum communication protocols. The adaptive communication network developed by the Global Cognitive Network initiated a multi-layered response that was simultaneously a greeting, a strategic assessment, and a demonstration of human capabilities. The Nexus vessels attempted to initiate standard pacification protocols, a series of technological disruption signals designed to neutralize potential threats. But the Horizon Nova's adaptive systems had already analyzed the incoming signals, creating counter-resonance frequencies that not only nullified the attempted disruption, but also began to extract critical information from the alien communication matrix. What followed was less a space battle and more a complex dance of technological and strategic innovation. The Horizon Nova did not attempt to destroy the Nexus vessels. Instead, it began to communicate, transforming the entire encounter into a comprehensive demonstration of human potential. Quantum entanglement communication systems created a bridge of understanding that went beyond traditional language. The ship's adaptive interface began to translate and interpret the Nexus communication in real time, revealing layers of cultural and technological context that the alien patrol had never anticipated sharing. Captain Rodriguez understood that this was more than a potential conflict. It was an opportunity to demonstrate humanity's unique approach to interaction. The ship's systems began to broadcast a complex series of mathematical proofs, cultural insights, and technological capabilities that challenged everything the Nexus Collective understood about emerging civilizations. The most remarkable moment came when the Horizon Nova's systems began to actively collaborate with the Nexus vessel's technology. Adaptive interfaces found common communication protocols, shared computational resources, and began to solve complex interstellar navigation challenges that benefited both parties. Dr. Elena Petrova, monitoring the encounter from the Global Exploration Command Center, watched in awe as the interaction unfolded. The traditional concept of first contact was being completely rewritten. This was not a confrontation or a simple exchange of information. This was a comprehensive demonstration of collaborative potential. The Nexus Patrol's command systems began to recalibrate their understanding of the human species. The initial assessment of humanity as a potential threat transformed into something far more complex. Here was a civilization that did not seek to conquer or destroy, but to understand, collaborate, and expand collective knowledge. As the encounter concluded, the Horizon Nova had not fired a single defensive measure. Instead, it had created a new model of interstellar interaction, one based on mutual understanding, adaptive communication, and collaborative problem-solving. Captain Rodriguez's final transmission to the Nexus vessels captured the essence of the moment. We do not seek to challenge you. We seek to understand, to learn, and to grow together. The Nexus Collective's monitoring systems struggled to process the encounter. Their most sophisticated predictive models had been completely invalidated. Humanity had just demonstrated that technological potential was not about destruction, but about transformation. As the Horizon Nova continued its exploration, the universe watched and waited. Something extraordinary was unfolding, a new chapter in interstellar civilization that no one had anticipated. The turning point had arrived, and nothing would ever be the same again. The news of the Horizon Nova's encounter spread through interstellar communication networks with unprecedented speed. What had begun as a potential confrontation had transformed into a comprehensive demonstration of human potential that challenged fundamental understanding of emerging civilizations. The Galactic Council chambers on Nexus Prime became a place of intense debate and reflection. Representatives from thousands of stellar civilizations gathered to review the comprehensive data package transmitted by the Nexus Collective's Exploration Patrol. The traditional protocols of first contact had been completely dismantled by a single human vessel's approach. Dr. Amira Chen, Earth's primary xenodiplomacy specialist, found herself at the center of a diplomatic revolution. Her team had been preparing for years, developing communication protocols that went far beyond traditional diplomatic approaches. The goal was not to negotiate from a position of strength, but to create a framework of mutual understanding and collaborative potential. Scientific. Institutions across multiple star systems began to study the human encounter with intense fascination. The adaptive technologies demonstrated by the Horizon Nova suggested a fundamentally different approach to technological development. Where most civilizations viewed technology as a tool of control, humans seemed to create living, adaptive systems that could grow and evolve. The Stellar Research Consortium compiled a comprehensive analysis of human capabilities. The report revealed a civilization that defied traditional developmental models. Humans demonstrated an unprecedented ability to solve complex problems through collaborative innovation, adaptive thinking, and a unique approach to technological integration. Research teams from various alien civilizations began to request collaborative projects with human scientific institutions. The Global Cognitive Network, originally developed as a human research platform, was now becoming a model for interstellar knowledge exchange. Educational and research institutions found themselves at the forefront of a new model of collective intelligence. Cultural exchange programs emerged as a critical diplomatic strategy. The first wave of human ambassadors were not traditional diplomats, but a diverse group of scientists, artists, philosophers, and adaptive systems specialists. They carried with them not just technological insights, but a comprehensive understanding of human creativity and potential. Dr. Kamau Okonkwo's work on adaptive communication networks became a foundational text for interstellar diplomatic approaches. His theory suggested that true communication was not about transmitting information, but about creating dynamic, evolving systems of mutual understanding. The economic implications were equally profound. Emerging interstellar trade networks began to incorporate human adaptive technologies. Economic models that had been stable for thousands of years were now being reimagined. Human approach to resource management, technological development, and collaborative innovation created entirely new paradigms of economic interaction. Environmental restoration technologies developed by human teams became a critical resource for multiple struggling planetary ecosystems. The adaptive approach that had been developed to address challenges on Earth now offered solutions for ecological challenges across multiple star systems. Smaller, less developed civilizations found a new model of potential progress. Humanity demonstrated that technological advancement was not about military might or resource accumulation, but about adaptive potential and collaborative innovation. The Nexus Collective's initial assessment of humanity underwent a complete transformation. What had once been viewed as a potentially dangerous, unstable species was now recognized as a critical source of innovation and potential cooperation. Dr. Amira Chen summarized the moment during a pivotal galactic conference. "We are not here to compete or conquer. We are here to understand, to learn, and to grow together. Our greatest strength is not our technology, but our ability to imagine possibilities beyond our current limitations." As the first wave of human collaborative missions began to explore beyond the solar system, something extraordinary was happening. Humanity was not just entering the galactic stage, they were fundamentally reimagining what interstellar civilization could be. The universe watched with a mixture of anticipation and wonder. A new chapter was beginning, one that no one could have predicted, but everyone was eager to explore. The galactic awakening had arrived, and humanity was at its center. The Galactic Convergence Center stood as a testament to a new era of interstellar cooperation. Located on a carefully constructed neutral station that orbited a binary star system, the facility represented the culmination of humanity's unexpected journey from an overlooked planetary civilization to a transformative force in galactic development. Dr. Maya Rodriguez, now the primary human representative to the Interstellar Collaborative Council, stood before a holographic display that mapped the intricate networks of cooperation that had emerged over the past decade. What had begun as a simple quantum communication breakthrough had evolved into a comprehensive reimagining of interstellar potential. The final confrontation was not a battle, but a profound conversation that would reshape understanding across thousands of star systems. Representatives from the Nexus Collective, along with delegates from over 247 different civilizations, gathered to witness a comprehensive presentation of human collaborative potential. Dr. Elena Petrova presented the core of humanity's approach. It was not about technological superiority or territorial expansion. Instead, humans had developed a unique model of civilization that viewed challenges as opportunities for collective growth. The adaptive technologies they had created were less about control and more about dynamic, responsive problem-solving. The presentation revealed technologies that defied traditional understanding, ecological restoration systems that could heal entire planetary ecosystems, communication networks that could bridge cultural and biological differences, medical technologies that could adapt to the unique biological requirements of multiple species. Each demonstration showed not just technological capability, but a fundamental philosophy of collaborative potential. What made the presentation truly remarkable was its approach. Instead of claiming superiority, the human delegation offered open collaboration. They shared critical technological insights, demonstrated adaptive communication protocols, and presented a vision of interstellar development based on mutual understanding and collective growth. Dr. Kamau Okonkwo's work on adaptive cognitive networks became the theoretical foundation of the presentation. His research demonstrated how diverse systems could create more robust, innovative solutions when allowed to interact dynamically. The theory challenged fundamental assumptions about technological and cultural development. The Nexus Collective's lead representative, a being whose name translated roughly to keeper of collective potential, found itself fundamentally challenged. The human approach contradicted every established protocol of interstellar interaction. This was not a species seeking to conquer or compete, but one genuinely interested in collective growth. Technological demonstrations showed systems that could adapt to multiple biological and environmental conditions. A single adaptive medical technology could potentially provide treatment solutions for hundreds of different species. Communication networks could bridge linguistic and cultural barriers in real time. Ecological restoration technologies could help heal planets damaged by millennia of conflict and resource extraction. The most profound moment came when Dr. Rodriguez introduced the concept of the global cognitive network. It was more than a technological platform. It was a living system of collective intelligence that demonstrated how diverse perspectives could create more robust, innovative solutions. Representatives from smaller, less developed civilizations found a new model of potential progress. Humanity demonstrated that technological advancement was not about military might or resource accumulation, but about adaptive potential and collaborative innovation. Dr. Elena Petrova's closing statement captured the essence of the moment. We are not here to lead or to follow. We are here to grow together, to learn from one another, and to create possibilities that none of us could imagine alone. The Interstellar Collaborative Council underwent a fundamental transformation. Traditional models of diplomatic and technological exchange were replaced by a more dynamic, adaptive approach. Humanity had not conquered the galaxy. They had invited it to reimagine its own potential. As the presentations concluded, something extraordinary became clear. The most powerful force in the universe was not technology or military might, but the ability to understand, to adapt, and to grow together. The ultimate revelation had arrived. Humanity had transformed from an overlooked species to a catalyst for a new era of interstellar cooperation. The universe would never be the same again.